Hi everyone, this is Dan Ames. I'm in the picture with Jim Nelson, Gus Williams, and Norm Jones at Brigham Young University, where we are working on the group on Earth Observations Global Water Sustainability, or GEOGloWS Toolbox project. Our project has three main goals. The first goal is about technologies for building Earth observations and water resources web apps. Our second goal is about technologies for moving these web apps and decision support tools around the web and customizing them. And our third goal is about creating some very specific decision support apps and putting them into the hands of our end users to solve specific problems. Who are our end users and stakeholders? They are water management agencies in Argentina, Colombia, the Dominican Republic, Brazil, and a consortium of agencies in Central America. Some of the needs of these agencies are documented in a recent document that I can make available to you if you're interested, called the GEOGloWS Water Sustainability Use Case Stories. There are other partners of GEOGloWS that have done equally cool and interesting tools and problem solving for other agencies and other countries that are also documented in this GEOGloWS document. Back to our project goals. For the first project goal, we have adopted and adapted the Tethys platform as a structural framework for our web apps. For our second goal, we have created something we're really excited about. It's called the Tethys App Store. We were calling it the Tethys App Warehouse, but everybody knows what an app store is, so we're calling it that now. It's for uploading and moving these apps around the web. And our third goal, well, we've got the GEOGloWS Toolbox, which is basically a collection of specific water resources apps that have been developed for our user community. Altogether, this is a big hydroinformatics challenge, and I'm going to spend the rest of my time talking about some of the specific hydroinformatics tools and technologies that we've built along these lines. Okay, so Tethys platform. I talked about this at a recent one of these exact meetings, and I described it as a big box of open source tools for making simple Earth observation and GIS user interfaces. That's a useful paradigm. It's also useful to think of it as a set of custom scripts, model files, spatial data, databases, data sources that are brought together through the cloud into simple web interfaces for engineers, decision makers, advocacy groups, and the public. And you can learn more about Tethys Platform at tethysplatform.org, and you can see what we and our Tethys Platform partners are doing over there. So when you're running Tethys Platform, really, what is it? It's a portal that looks like this, and it has apps inside it, and the apps can be launched and run individually, and each app is kind of a modular, portable, independently installed, independently debugged, and updated tool. So you can see the advantage of doing your apps like this rather than building a single sort of behemoth monolithic website with a bunch of spaghetti code in the background. This way, if something breaks, only that one app breaks, you can take it out, upgrade it, improve it, stick it back in, etc. So that's the sort of overview of Tethys portal and Tethys platform for those of you who have or have not seen it before. Our goal number 2 has involved creating something that I just called the Tethys App Store a minute ago. And the Tethys App Store builds on WebSockets, Conda, GitHub Actions, and the Tethys application framework to allow us to easily move apps around the web. And we found that a lot of our government agency partners don't want to use a website sitting at NASA or sitting at NOAA or sitting at a .us or a .gov or even a .com location. They want the apps to sit in their frameworks and in their environments. And so Tethys App Store was created to make that possible. It works like this. Here is our partner agency, Sika, and they have 4 or 5 apps that they're running inside their portal. If they want to get a new app, they run the Tethys App Store app. And it shows them a list of all the apps that live at the central repository. They can go to the GitHub for each one, learn more about it, install it. And for the apps they already have in their environment, they can either uninstall it or update it. So that's kind of a familiar paradigm, right? It's similar to what we do with our phones, but this is the first time we're aware of where it's really been applied for Earth observation-based decision support tools and apps on the web. And that's why we're quite excited about the potential for this App Store. Just looking at some of the neat things the App Store can do is when somebody's developing an app, they can specify custom settings. And then when the App Store is installing that app, it will prompt the guy or gal that's installing this thing, what are your custom settings that you need to put in. So if you have a custom path to local data sets, local configurations, local data sources, then that can all be customized during install time. We think that's pretty important and allows these local user agencies to install the app, but to install a custom version of it that meets their specific needs. Another cool feature of the App Store is it has this little plus button here that if you have developed a Tethys web app and you want to share it with the rest of the community, you can upload it and add it to the App Store using that button with just a few steps and a configuration that includes your GitHub URL, that kind of thing. All right, going to goal number 3, we talked about wanting to make some specific web applications to solve specific problems for our end users. Our flagship app has been now for a couple of years, the GeoGloWS ECMWF Streamflow Hydro Viewer. What this does allows a user to zoom in and click anywhere in the world and click a point on a stream and look at a forecast for the next several weeks of what's going to happen in that stream segment. That includes flooding, drought, etc. It includes the probability of exceedance of different levels and at different return periods. This is a very cool app. Now, we developed and prototyped it at BYU a few years ago, and in the last year and a half or so, ECMWF, the European Center for Medium Range Weather Forecasts, has picked up our modeling stuff and they've put it into production and they're running it now. So that's cool because we don't have to run it anymore and it's in production, and they share the Streamflow API and we can just access the API and pull down images and text and data sets and Streamflow forecasts and run them into our web apps that are used in the Tethys App Store. Some of the apps, I'll highlight here a couple of them that take advantage of that Streamflow forecasting API. One of them is this. This is actually a pretty cool one. It's the Hydro Viewer Creator. So we've created a Hydro Viewer as a Tethys app where you can go around and click and look at all of those things like I showed you a minute ago. But what if you just need one for Colombia? Well, this particular tool lets you upload a shapefile and it will spit out an HTML-only viewer that explores the forecast from the ECMWF forecasting tool. And it does it in just straight HTML so that it can be dropped in any web page. And some of our partner agencies have loved that because they can do it on their own non-Tethys platform, just any old web page they have. They can stick this up and they've got a fully interactive Hydro Viewer. I like that one. I think it's cool. It's empowering. Another very cool tool that it lives inside this GeoGloWS toolbox is the Water Data Explorer for the WMO Hydrologic Observation System, or the WHOS data broker. The WHOS data broker is a neat thing. We didn't build the WHOS data broker, but it is being built by the WMO, and it takes satellite data and in situ data and runs it through this data broker and spits it out in some standard data formats that we can now consume into our WHOS Data Explorer, create some plots and graphs and let the end users explore the data and slice it and dice it in some neat ways. The Meteorological Data Explorer is similar. It works on spatial data instead of temporal data, and it lets us bring measurements from satellites and in situ probes through the NASA Land Information System computer models and produces a number of, we take this sort of number of historical data sets and other essential water variables and make them all very easily explorable by somebody through that user interface. They can click and browse, zoom and pan, pull out time series, pull out subsets of the data. So that's another one of the tools that's part of this toolbox. We have 2 groundwater apps that are part of the toolbox. These are based on GRACE, and they combine GRACE with groundwater observations for imputing local measurements. So that's a sampling of some of the apps that we've developed as part of the toolbox. I just wanted to show 3 portals. Here's a partner portal with the Central America Information System of the Center for Water Resources Research. They've got 5 apps and the App Store that they're running. We now have our INDRI Dominican Republic portal up here, and they're running about 7 apps, and then the App Store in the middle. And then a new one is the Amazonia portal that now has 2 apps that come from that big group of apps in the toolbox and their App Store. Well, that's the end of my time, so I'll just close with a list of our recent publications, which you can go browse at hydroinformatics.byu.edu. These publications are all straight out of this project or very closely tied to this project. And they all link to the paper, so you can go look at them. These are all 2021 publications. And again, like I said, that's the end of my time, so I will end with a big thank you to the leadership team here, and thank you for you all for listening to my presentation today. Thanks.